Good evening to all. In this video, we will discuss how to convert ER diagram into relational model. Now we will understand how to convert from an ER diagram into relational model. First of all, we are going to discuss the rules to convert ER diagram into the relational model. ER diagram means, already we discussed, it has entities, each entity described with a set of attributes, and there is a relationship between the entities. So here each entity type we are going to convert into the table in relational, and whereas each single valued attribute is converted into column, or in another way you can call it as an attribute of a table. That means all single valued attributes becomes a column in the table or attribute in the table, and key attribute or prime attribute in an entity is converted into primary key in relational model. And if you have any multi-valued attribute in ER diagram, that must be represented with a separate table. And if you have any composite attribute, that is represented with components. That means, suppose see, there is a name is there. Name is a composite attribute. It is specified with a set of component attributes. For example, F name, middle name. F name means first name, middle name, last name. If you combine these three component attributes, then you will get the composite attribute. That means, what is this one? Composite attribute represented by components. That means name attribute is not at all there in the table. If you convert this into the table, this particular composite attribute is represented like first name, middle name, last name. Okay. Here in this diagram, name is a composite attribute. That is a combination of component attributes. They are first name, middle name, last name. If this composite attribute, if you are going to convert into the relational model, this will be like this. So here component attributes are first name, middle name, last name. That means if you are converting this particular name composite attribute which is in ER diagram, if you are going to convert that into the relational model, and these attributes will come into the picture in the relation model, and this won't come. That is the meaning of this particular composite attribute represented by components. Okay. Then derived attributes. You understood that age is a derived attribute, whereas date of birth is stored attribute that has a fixed value. But derived attribute, it varies with respect to when you are going to see the value. So derived attributes are not considered in the table. That means if you are converting that derived attribute into the relational model, that won't come into the picture. These are the set of rules to convert from ER diagram into the ER model into the relational model. Okay. No doubt relational model means it is in the form of table. Now we will consider the same college ER diagram what we discussed in the previous video, and that particular ER model or ER diagram we are going to convert into the relational model by considering these set of rules. This is what we discussed in the previous video, that ER model. Okay, it has 4 entities. Each entity is specified with a set of attributes, and each entity is specified with a primary key and the various relationships. Okay, now see, we have, for example, see here, now this particular ER diagram we are going to convert into relational model. Before going to that, now we will consider this ER diagram and we will convert this into the relational model. Let us say entity 1 is the student, entity 2 is the course, whereas entity 3 is the faculty, whereas entity 4 is the department. In this ER diagram, we have 4 entities: student, course, faculty, department. Let us consider student entity E as E1, E2 is course entity, E3 is faculty entity, E4 is the department entity. We understood that each entity is converted into a table. Okay. Now we are going to see here. Student is E1, so you can call it as a T1, table 1. Course entity is E2, so you can call this as a T2. Faculty entity is E3, so you can call this as a, for our understanding, T3. Department is E4, so you can call it as T4. That means 4 entities are converted into 4 tables, but attributes we need to check. That means these 3 attributes we have in entity 1. Okay, in entity 2 you have CID, CNAME, credits. Up to this it is okay. For faculty you have FID, FNAME, age. For department you have department ID, department name, and location name you have. Location or location name you have. Okay, there is a, we have to concentrate in that more. Okay, these 4 entities okay. That means these 4 tables are okay. That means T1, T2, T3, T4. But we need to check the different attribute, that is something like DID here, FID DID here, here DID, here something like location ID. We will see one by one. Let us again, we will go to the previous ER diagram. These 3 attributes are over, but here we need to check. See, here student department, what happens, many to 1 is there. You need to give connection between these 2 entities. That means department has student. This is a relationship. What is the relationship here? From department side 1, student side M. That means many, 1 to many. So many side you have to keep the foreign key and you have to give the connection here. That means always foreign key references to primary key. So department is the ID, department ID is the primary key in department. But if you want to combine these 2, department ID you have to add here and call it as a foreign key. Okay. See, because many side we need to consider the foreign key. See, here department ID is there. We want to give connection between these 2. That means what happens, whatever the primary key is there here, this primary key you have to add here and give connection to this one. This is a primary key, so this is a foreign key. Foreign key is going to give the connection between these 2. This is the way you are going to convert that relationship, that connectivity you have to give like this. Again I will repeat. So here many side is there. In ER diagram, this is many side, this is one side. So here you have to, what you have to do, you have to add a foreign key. Okay, that foreign key must be the primary key of other table. So that you have to take it as a foreign key and you have to give connection like this. So that connection is over. Then similarly, if you consider course and faculty, course side you have many, whereas faculty side you have 1. So this faculty side FID is there, primary key, that you have to add to the course table as a foreign key and you have to give the reference like this. That we will see. Here see, faculty side FID is there. This FID you need to add here. This FID you need to add here as a foreign key. That foreign key you need to give the reference to the primary key. Okay, this is also over. Okay, this is also over. Then if you consider the enrolled relationship, that means thought by relationship is over, has a relationship is over, then we are going to see the enrolled relationship. Enrolled, it has a relationship between course and student entity, but both are many side and it has another attribute also. So what we can do is, we can take a primary key here for giving the connection with the student. You have taken the primary key here, that is CID, SID, and it has already one attribute. That means enrolled you have to convert into a table that contains the attributes SID, CID, grade. But SID is a foreign key in enrolled, CID is a foreign key in enrolled, and grade is another attribute. Enrolled is one table, SID, CID, grade. Grade is an attribute for the enrolled, whereas SID is the attribute of student, so it is a foreign key. And here CID is a primary key in course, so here it is a foreign key. Then why you have written like PK? That means what happens here, for this table SID comma CID is a primary key combinedly. That's why here we are writing PK. That means these two combinedly primary key, not a single one. Suppose SID is not a primary key in enrolled, CID is not a primary key in enrolled, but SID comma CID is a primary key. So if you ask SID means SID is a foreign key, that's why 1, 2, but here nothing like that. So SID is a foreign key that references to primary key of student, and CID in enrolled is a foreign key that references to CID of course. Okay, that means conversion of that relationship, enrolled is into a table and SID is a foreign key. Okay, CID is a foreign key, SID comma CID is a primary key for this enrolled table, and grade is another attribute. This is over. Then the remaining we need to check. Let's go to the ER diagram. See, department offered many courses. That means this is one to many. Many side you have to put this particular DID as a foreign key. Okay. So department offered courses. So this DID you have to put here as a foreign key, and you have to give connection to the DID of the department. Okay. Because this is many side. So this is over. This is over. Okay. Then another one, faculty department we need to check. Faculty department, that means many faculty works in one department. So this DID you have to take it as a foreign key and add it into the faculty table, because this is many side. So DID you have to add it as a foreign key here, in faculty, and that you need to give connection to the DID in department, that is a primary key. This is also over. Okay, and another thing is that this collection if you consider also no problem, if you won't consider also no problem. Why? Because see, whether these tables are connected or not we need to check, because we are saying that this is a database. In database you have many tables. So student, that means if I want to go from student to something like a department, there is one way is there, other way we will check. Student enrolled course to faculty to department. So the course to department, how you can go? Either directly you can go course to the department, otherwise course to faculty to department also we can go. It's up to us, we can keep or not. Okay, but no problem. Then the last one you need to consider. Okay, that is we'll go to the ER diagram. See, in ER diagram this is a multi-valued attribute. Location is a multi-valued attribute. This multi-valued attribute, what we need to do? You need to create another table for that. That means in department the location attribute is there. For location attribute, multi-attribute, you need to create another table and you need to give connection with that table to the department. That means you need to create a location another table and give connection to the department. So location another table. Okay, in that location name is there. Instead of location, here in department earlier here location is there attribute. That location, that is a multi-valued attribute. For that you are creating another table that named location, but it has attribute like one connection is needed, that is location ID. Okay, and location name, another attribute. This location ID is meant for only for connection. That means what happens here, this is one table. For this table, this location ID is the, for this table location ID is the primary key, whereas the same thing you have to give here and call it as a foreign key, thereby you can get the connection. That means each location, if it is a multi-valued attribute, you need to create another table and you need to create a primary key for that table, that is called as a location ID, and you need to give connection with the parent table, that is department table. There you have to keep the location ID and that is called as a foreign key in the department table. Then you are going to give connection between these two tables. That means this table also over. Okay, this connection also over. I think all are covered. Am I right? These connections also we understood, okay, earlier. So this is about the total scenario of the how to convert that ER diagram into the relational model. Thank you one and all.